Okay, so we're back to the contradiction from the formula sheet. It's not actually a contradiction, but the fact that um, what you have to do is you have to assume that your initial theory is correct, and then you have to just continue forward with that theory until you find something that contradicts it, and then you have to figure out why. So if you just continuously go back and change your initial theory, you'll never actually find out if it's true. So what you have to do is you have to assume that the initial calculation that you did is correct, and then you have to assume the second one is incorrect, and then you compare them and try to figure it out from there. But if you assume nothing, then you'll never come to any realistic conclusion. So the scientific method is you have to have a hypothesis, and then you prove the hypothesis. So my hypothesis is that the contradiction from the last video, there isn't actually a contradiction. It's just that there's a piece missing. So I didn't consider everything. So what we did is we took this top piece going from here to here, and then I'll write in delta V A to B, is equal to, it could be, I2 R2, it could be I3 R3, and it could also be Vx plus Vs. So remember that V is equal to IR, I is equal to V divided by R, where I is the current, which is amps, V is volts, and then R is ohms. Right. So if we're just going, the delta V is obviously just Vx plus Vs. So the change in V, right here, V is 0. When we get to here, V is just Vx. When we get to here, V is Vx plus Vs. So here, V is 0. And when we pass this point, V becomes I2 R2, because V is IR. So I should write this as Vn In Rn. So what N is any value in series. So if I have a series and it goes 1, 2, 3. So that's the series for this. So that's from calculus 2. So here we have 1, 2, 3 R's, we have 1, 2, 3 I's, and we have 1, 2, 3 delta V's. So that means the series goes from 1 to 2 to 3. So N is any value in the series. Okay, so as long as so what this means is that Vn, so I select an N, so if I pick 1, V1 is I1 R1. Okay, so whatever N we choose at the start of the formula has to be the same N that we're plugging in at all other positions. So that's what this value of N is. So if I choose 3 as the value in the series, then it has to be I3 R3. So V3 equals I3 R3. So I can't choose N to be 2, and then in a different spot I choose it to be 1, in a different spot I choose it to be 3. It has to be the same value. Right. So N doesn't have more than one value. So N is just N. Right? So like if I say X can't be 1, 2, 3, and 4. Right? X just has one value. It's like I can't be 27, 28, and 29 years old all at the same time. I'm just 27 years old. Okay, so if I put in 27 for my age here, I can't put in 28 for my age here and 29 for my age here. My age is the same at all points in time, in time. So if I'm 27 now, I'm 27 all just like, that's just how I am. So my liver is 27 years old, my brain is 27 years old. And if V is V1, then I is also I1 and R is also R1, right? So if N has to be consistent when you're applying it, okay? So what we did before is we know delta V is just Vx plus Vs. And then we did a source transformation where the rules for the source transformation is if you have a resistor, this is a resistor, and you have a voltage source in a series, that's the same as having a current source parallel to a resistor. Okay, so a current source parallel to a resistor, so these two things are the same. And this is what I'm going to call this IS2 because we already have one input current source here. So this is the second current source. And these things can't exist simultaneously. So this piece is the same as this piece up here, and we're just saying theoretically that these two pieces are equal. And what it does is it gives us an additional value for the delta V, right? Because in this case, V is just IR, and what we have is we have I and we have R. So what we get here, delta V is Vx plus Vs, where Vx is the voltage across this resistor, and then Vs is just the voltage source. What we have here is we only have Vx because Ix doesn't have, it's just a current, so theoretically there's no like voltage value for it because it's just an input current. Okay, so, and this isn't Vx, you could call this like V theoretical, like just like, I don't know, V question mark. This is a theoretical V, right? So what this means is that V is IR. So in this case, delta V is just IS2 times R. We'll just keep it as R in this case, okay? So the contradiction here occurs when you realize that IS2, okay, what is I? We said I is V over R. So IS2 is delta V divided by R. So what you get is delta V is just equal to V divided by R. Or sorry, delta V is just equal to V question mark. Because IS2 is equal to V question mark divided by R. This is V question mark. So if you sub this value in up here, what you get is delta V is just equal to V question mark. Okay, but what you need to realize is that this value is contradictory because over here we have delta V is this resistor, because this resistor value is the same. When you do the source transformation, it doesn't change the resistor value. So what we're not considering here is that when you make this parallel, you still have this I1 that is going into the circuit, and it's continuing up this way. And then you also have this IS2. So you have two currents. So the actual value of delta V in this case is actually equal to I1 plus IS2 this is just gross. I1 plus IS2 times R. This R, which is the same as R up here, which is R1. Okay, so if we put these together, we say IS1 plus IS2, times R1 is equal to this delta V up here, which is Vx plus Vs. what we have is IS1R1 plus IS2. Sorry, this should not be S. This should just be I1, because this I1 is the same as the I1 up here. Right. So you have I1R1 plus IS2R1 is equal to Vx plus Vs. So IS2R1 is the same as Vs according to our source transformation formula. So here we have V equals IR, right? So this V here is just IR. So this is Vs. So this is the source transformation formula where we say for a source transformation, Vs is equal to ISR, and Is is equal to Vs over R. So this is just for any source transformation. Okay. So for any source transformation, you go from series to parallel. Right. This is the formula that you get. Okay. So what we get here is equal to Vx plus Vs. So this, this is the same as this. And then I1R1, if you go up here, is Vx. So these are the same. If I don't include this I1, which is the same current that's up here, so the idea is this parallel resistor, it would be attached like this, and it would come across like a box up here, and then all this would be erased, and you would just replace this with that. So this is the actual value would just be with the included current. So you still have to include the current that is going into the wire as part of the value for the V that's going across here to here, but you don't include the input current that's going into this parallel just to find the values of R.